welcome to Sequence Showdown, the only game show where we put the fun in function and the ow in power roll.
Today we're tackling arithmetic and geometric sequences because math never quits and neither do we.
Let's get right into round one, name that sequence.
Alrighty, here's the sequence. 2, 5, 8, and 11.
That's easy. That's an arithmetic sequence. You're adding 3 each time.
Ooh, what a brave volunteer. Now we'll show you how you do it.
See here, if you start at 2 and go up to 5, that's adding 3. Then you add another 3, then you add another 3. 3 is the common difference. So, D equals 3.
Another sequence, 5, 20, 40. Anyone know what kind of sequence that is?
That's easy. Geometric sequence. It's multiplying by 2 each time.
Thanks, Carson, for hitting us with that common ratio. Now here we'll do some explanation. So, your first number is 5. How do you get from 5 to 10? Sure, you can add 5, but that's also doubling. So, if you multiply by 2, 5 plus 5 equals 10. If you multiply 10 by 2, 10 times 10, 10 plus 10 equals 20. If you multiply 20 by 2, 20 plus 20 equals 40. 40, which is this number. So that's how you got there. That's a geometric sequence. Go.
The difference between an arithmetic and a geometric sequence is that for an arithmetic sequence, you're adding by a certain number, and for a geometric sequence, you're multiplying by a number.
For the first one, we added 3 each time, but for this one, we just multiplied by 2 each time.
Which makes it a geometric sequence.
Boom. Okay, now we're gonna explain what to do if you need to know. If you start with the number 3 and you know you're multiplying by, let's say 2, and you want to find like the 17th term in the sequence.
I don't know, I thought my teacher would.
Okay, next up we have our first arithmetic sequence problem. So, if you have a 3 equals 7, cut it. Okay, so for our first arithmetic sequence problem, if you have a of 3 equals 7 and a of 8 equals 17, what's a of 11? So what you're going to start off is by putting this number and this number and this number and this number into 2 points. So 3 would be the x and 7 would be the y. 8 would be x, 17 would be y. So you have 3, 7 and 8, 17. And with these 2 points, you're going to turn them, you're going to find the slope. And you do that by the slope intercept. Yeah, formula. So you're going to have 17 minus 7 over 8 minus 3, which equals 10 over 5, which equals 2. Got it.
Wow, I'm really starting to understand this stuff.
Oh, don't worry. We still got a lot more learning to do. So, now that you know that your slope is 2, you're going to turn it into slope-intercept form, which is y equals mx plus b. But if you know math, you know n is the slope. So, we can replace n. So y equals 2x plus b. And now, you're going to take one of the old points we had before and plug it in for y and x. So one of the points we had was a of 3 equals 7, so we can easily substitute that in. So we have 7 equals 2 times 3 plus b. And from here, you want to solve for b. So 2 times 3, 6. 7 equals 6 plus b. And now we want to isolate b. So we subtract 6 from each side, which leaves you to 1. B equals 1.
Oh, that makes so much sense.
All right, and now what we have to do is we have to substitute b and slope. All right, and as we said before, we're trying to find what a of 11 equals. So now we can plug in 11. So we have a of 11 equals 1 plus 2 times 11. And 2 times 11, 22, plus 1 equals a of 11. A of 11. 22 plus 1 is 23, which equals a of 11. And there you go.
Yay!
Wow, I think my brain just expanded by a of 11.
Unfortunately, we lost our audience, but we're still here to teach you guys, and Carson's with us in thought. So today we're going to be looking at a geometric sequence and the difference between that and an arithmetic sequence. So this is our formula for a geometric sequence. It's going to always look like this, and we're looking for g of 6. So g of 1 in our problem equals 5, and the ratio is -2, which means that we're multiplying by -2 each time. So we're going to replace the g of n with 5, and then do g of 0, and then our ratio, replacing this r, and then exponent 1. Okay. And we're going to try to isolate the g of 0 and divide it by -2 to get rid of this, which makes it equals g of 0. For this problem, the exponent doesn't really matter since it's just 1, but in other cases it might matter.
Okay, we're still not done. We still have to find g of 6. So now that we know that g of 0 equals -5/2 and our ratio is -2, we can work with that. So you're going to plug those into our formula. Our formula is g of n equals g of 0 ratio to the n. So we're first going to plug in we're finding g of 6. So we're going to do g of 6 equals g of 0, which is -5/2, and then our ratio, which is -2, to the 6th. And if you know math, you know 6 to the -2 is 64. So g of 6 equals -5/2 times 64. Okay, now we have -5/2 times 64, which equals -160. So you have g of 6 equals -160. And you also have g of 0 equals -5/2. Voila.